sample size, but no one's ever really seen that before. So even right now, in some of the most difficult cancers, some of those new ideas are taking off. So the last thing any of us would want to see is a great cancer vaccine running into a lot of vaccine skepticism.
Yeah, absolutely. There's a lot of other stuff that I know interests you, and I think, again, some people in the audience will be well acquainted with, but others won't. You know, we were talking backstage about genetic engineering, and I was saying that kind of brings to mind, you know, Dolly, the sheep, and designer babies. So maybe if you could just disabuse anyone in the audience who's sort of worried about those two words together, what's happening on that front and what excites you, that would be great.
Absolutely. Well, first of all, I think it's worth noting that these ethical concerns are really healthy to have. One of the key pioneers, Jennifer Doudna, who's right next door in Berkeley, has been really on the front lines of suggesting that we need to be, you know, doing research here with a lot of oversight, a lot of caution, and a lot of deliberation. And I could not agree more. And she's the most qualified person in the world to think so. However, right now, we are very, very, very far away from the, you know, designer baby scenario. What we have right now is the early stages of gene editing technology. So a good way to think about this is, if you think of ultimate gene editing as like copy paste, you know, you have a bad thing, you want to replace it with a good thing. We're right now about 50% of the way there. We can cut with great single gene specificity, and that we can do quite well, but we can't paste. We're not good at putting in something better. So just off the bat, I would say our technology, you know, full stack for what we need to do is still very incomplete. And that's something that we're funding research on, and it's an area that we're very focused on. However, there's quite a lot that you can do with eliminating single things. So for instance, sickle cell anemia is a major disease, particularly in the African American population here. And it's caused by a single point mutation in your red blood cells. And it actually is the case where if you can knock out that one bad gene, and it's a dominant gene, your recessive gene, which is normal, can function well. And we're seeing early data of this disease actually being cured, truly cured with this single gene knockout. So right now there's several diseases that are, you know, they're called autosomal dominant, where it's one bad copy. Huntington's disease, which is a horrible neurodegenerative disease. Sickle cell is a great example as well. These things can be really knocked out with just single gene specificity, and we're already starting to see some of that. So those are the areas where we get really excited, and right now that's probably the limits of what we can do right now in humans.
Okay, great. Well, that sounds significant. What about epigenetic engineering? That's another thing that came up on our call, and I was like, Reed, explain it to me. Tell me what's so exciting there, and maybe what you're funding.
I'd love to. It's actually one of the areas that we're the most excited about. So if you think about epigenetics, a good way to kind of mentally model it is every cell in your body has the same DNA, right? But clearly, you know, your liver is significantly different than your skin. So the way that works is, if you remember biology, your chromosomes, and you have 26 of them, you basically have your DNA rolled together with these various proteins. And you can chemically, without changing the DNA, turn on or off various areas of the genome. So your skin cell will just turn off all the liver genes. It doesn't need it, right? Well, how that works can actually now be perturbed, and we can change it a bit. And it turns out a lot of diseases are not caused by mutations or by the wrong gene. They're caused because gene expression goes down. A lot of neurodegenerative diseases, and actually a lot of autoimmune diseases, are caused because your immune system slows and it becomes exhausted. And it hasn't changed genetically. The expression levels go way down. And with what we're doing now, we can actually turn it back up. You can create a dial. And some other diseases, of course, are caused by things becoming hyperactive. So in those cases, you want to do the inverse. And that dial is really interesting, and you can actually touch a whole new class of diseases with it that are much more interesting than just actually going in and changing things. So that's another area that is distinct from gene editing, but it's actually probably going to happen in the clinic closer just because the safety is a lot better.
Great. I guess with either of these, are there sort of downsides that concern you? I mean, I mentioned sort of the obvious, sort of cartoonish version of the concern about genetic engineering, but with epigenetic engineering, are there sort of concerns that you have about it being, I don't know, used in wrong-headed ways?
Of course, now with any type of genetic or epigenetic perturbation, you're going to have really clear ethical guidelines for all this, which is why all of our companies publish data, all of our academics publish everything, and there's a really good ethical framework that's been developed internationally about how these things need to be developed, how they need to be disseminated and shared. And I'm happy to say that right now, everyone is really focused on mainly two areas. One is disease mitigation, and one is climate change. And there's actually huge applicability in both of those, and that's really where I'm spending all my time.
That's great. And tell me about the impacts of AI on what you're doing. I saw today that Mark Zuckerberg at Priscilla Chan announced that they're putting, I think, like $100 million into this generative AI, computing power thingy. And I'm just wondering if that's something that you've talked to them about or following, and just generally speaking, what you expect the implications are here.
Sure. So Steve Quake, who's the scientific director of the Chan Zuckerberg Initiative, is someone who I interact with quite a bit professionally, absolute rock star, and his predecessor was as well. So they have some great people there. What they have done is actually,
How's it going? How's your day going so far?
right now, it's pretty remarkable. What we're seeing is AI is making scientists significantly more productive by accelerating research, and it's also probably going to be accompanying them as they come up with different theses. So I'd say the two mechanisms of that is first, what we're seeing is a lot of great modeling, and this is what CZI is going to be working on. Modeling protein folding, modeling genetic engineering, and doing that in actually a real 360 cell is going to accelerate development tremendously. It's hard to put a number on it, but it's a huge shift. And the second version, though, is really looking through all the scientific literature that's been published. I mean, when you're in medical school, part of your job is to try to absorb all the scientific literature that has ever really been made available, which is pretty impossible to do for a single person. And now what we're seeing is once that is actually filtered through a lot of really good next-gen AI algorithms, that is actually yielding insights that are getting to be pretty close to as good as what humans can do. And if you extrapolate out a few years, it'll probably be something that'll accompany researchers.
Terrific. I just wanted to ask you, so you've been doing this for 5-7 years longer, possibly. What is the most impactful investment that you've made to date?
Oh, great question. We've been doing this for 8 years, and I would say by far the most impactful, I'll say a grant and investment. So there's a grant that we did at Yale, which I'm extremely proud of, which worked with their main hospital system to actually get clinical trial representation from across the state from a lot of physician providers. It worked great in Connecticut because it's a small state with like kind of one big academic medical hub in it, and they actually got representation be demographically proportional, which I'm really, really proud of. That's the first for that entire institution. And on the company side, I would say one of the company that we're probably the most proud of is one called Tune Therapeutics. It's one in the epigenetic editing space. It's something that it was our first incubation that my team did before we joined Yosemite while we were at Emerson. And I'm really proud of it because at the level that we're at across all these labs, we were able to see connections that were obscure to even the best researchers in the world. We paired up the best expert on this type of editing plus the delivery mechanisms that you're going to need to get into cells, and they didn't even know each other. So we actually introduced them in my living room and sketched out the business plan, and I'm just proud to say it's really become a leader in the space in the last 3 years.
Terrific. And, so you mentioned incubating this company. Is incubation a big part of what you're going to be doing at Yosemite? And if so, how does that sort of differ when you're talking about giving these very early stage grants to scientists? I guess, should they be worried that you're going to be competing with them?
We don't think so at all. So, of course, incubation is a huge part of what we do. As you can imagine, scientists really begin in this journey because they want to see a change in patients. They're not in this to make a lot of money or necessarily to have a great academic post. They're really in it to solve a problem. And companies are the only vehicle that exists to really do that at scale. So entrepreneurs and academics could not be more excited to actually get things into the market as quickly as possible. And for us, since we take no IP or royalty strings at all, our view is that we hope to be, their first port of call. However, the onus is on us to earn it. If they go with another firm, that is because we haven't earned it, and we need to do better.
And do you have a lot of competition? I mean, obviously there are lots of, health sciences investors. Are more people, I feel like I'm talking to more people who are focused on or very interested in learning about the intersection of AI and healthcare. Are you seeing that on the ground?
Absolutely. However, one big difference between tech and biotech is that in the life sciences, early companies are much more capital intensive than what you have in the early stage on the tech side. So yes, it's competitive, but elbows are a little less sharp simply because a Series A, it will not be $6 million, it'll be closer probably to $50 million.
Right. And in terms of, I guess, what you are going to be funding at Emerson, so it's a $200 million fund. Have you made any investments yet?
Yes, I'm proud to say we have. We had a few things that we were really excited to debut with, and those include a next generation gene editing delivery platform, a really interesting new startup that just came out of MIT, and another one that is out of Yale that we're about to close, and I can't talk about that one yet because it's not done, but it's going to be really cool.
Well, based on your sort of view into all of these different sort of verticals, do you have any reason to think that cancer will not be a chronic disease versus fatal in the next 25 years? I mean, what is I've heard you say something about the next century, but do you think we could even be closer, or do you think even that's maybe too ambitious?
Well, I'm all for being ambitious. Biotech is never as linear as tech. It's always it abounds in mystery and difficulty, which can be very exciting. What I believe is that the major cancers which claim most lives are right now seeing the greatest progress, and that really enervates me. That's lung, it's breast, it's prostate, colon. Those are the really big killers. And I do believe that in the next 20 years, we're going to see a very significant decrease in mortality there. Of course, cancer is a very heterogeneous population, so there will be a few outliers. If I had to speculate, cancers that like ovarian, brain, and unfortunately pancreatic are going to be a bit more difficult. They have low mutational rates, they're hard to detect, they have these weird, horrible microenvironments that are very suppressive to anything, really getting in there. And I think, unfortunately, those will likely sort of be the final outliers. And we will stay on to the end here at Yosemite. We are not going anywhere. We're really not going to go out of business until we see mortality decline to a level that people don't die of cancer anymore.
I love it. Reed, we're going to have to go here in a second, but I also just wanted to talk to you as a Bay Area native.
Yes.
The San Francisco Bay Area has obviously gotten a lot of grief. I'm just wondering, do you want to sort of tell us why you think people have it wrong?
Well, I am likely the most biased person you're ever going to talk to, because I was born in Palo Alto, I went to Stanford, and I very proudly have lived in San Francisco for the last 9 years. I think the Bay Area is the most beautiful place in the world, and it will always be home. The Bay Area, if you look historically, has been a lot like a phoenix. it has had booms and busts that have been extremely like volatile all throughout its history. And every time, there's a bit of a downturn, there's always a lot of naysayers and, this is the end, what were you thinking? And consistently that has been proved wrong. And already, I promise you, already there are companies, young companies that are very excited to be here, talent that doesn't want to look anywhere else, and capital. And you mentioned AI earlier. AI is not happening in other parts of the country.
Right.
It's happening here in San Francisco.
Yeah. No, it's exciting, and you can just see the energy. I mean, obviously at this show, but elsewhere, I mean, the restaurants are buzzing, people are out on the streets, and it feels like the city has really come back. I mean, obviously we have problems to overcome, but
That's exactly right. Well, I see we're at time. I actually just want to end by thanking you for putting on such a wonderful inaugural event.
Oh,
Congratulations.
thanks. It's amazing. Thank you so much. And thank you all.